Okay, I've got a TR6 block in the CNC machine. This block was machined previously, board, deck, etc. And I'm checking it out. This customer is spending a lot of money on this engine, building a nice engine, wants it perfect. Now I'm just going to demonstrate why a machine that bores from the pan rails, bores end decks from the pan rails as a reference is not always a good idea. Now, of course, in a CNC machine, it's mounted on this 2-inch bar right on the main, so it's exactly perpendicular to the spindle and parallel to the table. And everything really should be referenced off the main line. But I've got a dial indicator on the pan rail here, and I have it set at 0. I think you can see that pretty well. Now I'm going to traverse the length of the pan rail. See, I'm going down the pan rail, and you watch that indicator. Now we're at 5, almost 6 thousandths. We are at 6 thousandths height difference front to rear, and this is not untypical of a lot of blocks. Now we're going to rotate the block around. The deck I'm doing this all manually cranking, so it takes a second. We'll do the same thing on the top. Now this block, like I said, has been decked previous. I'm going to make sure it's still level. Yeah, I've got it leveled front to rear. Now I'm going to just run the indicator down the length of the deck, and we'll see what the effect is. As you can see, we've got almost 5 thousandths difference. It's actually more than that because this block has got some twist in it also. This side of the block, so this side it measures 6 thou, so there's a 2 thou twist in this block as well. But that's the result of a machine that referenced from the pan rails. And if you're building an engine to performance specs and you want the piston height to be the same one end of the block to the other, it really needs to be done on a machine that references from the main line. So I'll do a minimum cut on this block to correct it, and then he'll have equal height compression distances.